here are your homework corrections, so the work I gave you on Monday the 11th. So I gave you a question that said a rough plane is inclined at 30 degrees to the horizontal and has a smooth light pulley attached to its uppermost point. A taut light inelastic string passes over the pulley and has a mass of 3 and 2 attached to its endpoints. The coefficient of friction between the 2 kg and the plane is 1 over root 3. 3 kg mass hangs vertically, system released from rest. 3 kg mass moves vertically downwards. Let's go through it bit by bit. We have a rough plane inclined at 30 degrees. The 2 kg one is on that. So first off, there's a 2 kg mass. If there's a mass, there's a weight. Actually, not first. If there's a mass, there's a weight. Second of all, if the 2 kg is resting on the plane pushes back, so there's a reaction. That's that one. The third thing, there's a string attached to the 2 kg, so that means there'll be a tension acting on the 2 kg there. And the fourth thing that we spot is that the 2 kg is on a rough horizontal plane, so there's friction, like so. Now we know friction is going down the plane like that, because if the system were to move, it looks like the 3 kg would go down vertically and the 2 kg would slide up along the plane. That's what the red arrows represent, the acceleration of the bodies. So you've identified all the forces. The next thing to do is make sure you've got the forces that are acting parallel and perpendicular to the plane only. The only one that we need to worry about is the weight, which is 2g, which I haven't put in, but it's the one that's vertically down. So we need to resolve that into two components, like so. The angle there at the top of that right angle triangle with the two dotted arrows and the solid arrow, which is the weight, is 30 degrees, and we have opposite and adjacent there. So to calculate the opposite and the adjacent, we would have that. Okay, that's a start. Let's go to the marking scheme and we'll go through it bit by bit. Alright, so you'll see there on the right hand side, I've banked the opposite and the adjacent, and like with all connected particles questions, we need to assess the particles separately. So I start with the one on the left there, which was the 2 kg mass on the plane. And we can see from that there's 2g downwards, there's a tension caused by the string upwards, there's a reaction, which is the one to the top left hand corner, that's perpendicular to the plane. And then we have friction, which is parallel to the plane, which is mu r. And like I said, the only one that's not parallel or perpendicular to the plane there is the 2g. That needs to be resolved into two components. Okay, obviously I didn't do that. So we should have a component down like so and a component down like so. Right. The component like that will be the 2g cos 30, and the component that's going parallel to the plane will be the opposite, 2g sine 30. And we get rid of that one then. So what we're saying is the 2g is now represented with its two components, the opposite and the adjacent. Look, with the opposite and the adjacent. So we can get rid of that, and that makes our analysis a little bit easier. Okay. The next step then is you want to have a look at f is equal to ma with this block and f is equal to ma with that block. So I'm going to go back to the marking scheme and I'm going to start with this one. So we know it's accelerating down. So downwards we'll say is positive. So 3g will be positive, t will be negative, and we'll get 3g minus t is equal to 3a. That's from f is equal to ma. And when I rearrange that, it gives me t is equal to 30 minus 3a. Now the 30 technically isn't right. This is an ordinary level question and they take g as 10. You should be putting in 9.8 there. But that's what they get for this body here. Now let's look at this one. So we know there's an acceleration in that direction. We know the acceleration is up the plane. So I'm going to say up the plane is positive. I'll have a t, which is positive. I'll have a mu r, which is negative. And I'll have this thing here, which is the component of the weight parallel to the plane, which is downwards as well, also being negative. So that is this one. And then the third equation is perpendicular to the plane, like so. There's no acceleration perpendicular to the plane. So as a result, that force minus the component of the weight perpendicular to the plane, which is that, are equal to 0. And when you rearrange it, you get this thing here. So you've got three equations, and we now need to solve for what we're looking for. So we have the separate diagrams. We're looking for the acceleration and the tension. If you're looking for the acceleration, it makes sense to cancel the t's here and here. So instead of or, I'm going to put in 2g cos 30 in there. I'm going to take the mu value that's given, and then I'm going to set up my simultaneous equations and cancel them off. So they've done it slightly different. T is 30 minus 3a, they've put that in there. Mu is 1 over root 3, and r is 2g by cos of 30, which is g root 2. It's equal to 2a. Solve for a is equal to 2, and then sub that 2 value back into that equation to get the t. T is equal to 24 newtons, roughly. You'll have slightly different values to that, but if you're around the ballpark for those, I would say the question is correct. Okay, number 2. So 2007b. I'll interpret it as we go. We have two masses connected by a taut, light, and extensible string. If it's taut, it means that the acceleration of one will be the same as the acceleration of the other. If it's light, it means we can ignore its mass, or its mass has no effect, so we don't have to apply F is equal to ma to the string. If it's inextensible, it means it's not behaving like an elastic band or a bungee cord, so if one of them moves, the other one moves with exactly the same velocity all the time. The string can't stretch, and at no time will the two particles be moving at different speeds. Right, pass over a smooth, light, fixed pulley. It's light, so we can ignore the mass. Smooth, no friction. And if it's fixed like that, in this particular case, we generally ignore it when we look at F is equal to ma. Next paragraph or sentence. The 6 kg mass lies on a rough horizontal plane. 6 kg, if there's a mass, there's a weight. If it lies on the plane pushes back perpendicular to the plane. The plane is horizontal, so as a result, the reaction will be straight up. It's on a rough surface, so friction is present. So we'll see in a moment that the 6 kg will go to the left, I think, so friction will go to the right. And we're told the coefficient of friction is 2/3. 10 kg mass lies on a smooth plane. Okay, it's got a mass, therefore it's got a weight vertically down. Lies on the plane, so the plane pushes back with a reaction, that's towards the top left-hand corner, perpendicular to the surface it's on. There's a string connected to it, so we have a tension, and it's frictionless, so that section is frictionless. Now we're also told that the plane is inclined at an angle alpha, and tan of alpha is equal to 4/3. For simplicity, calculate alpha to start with. Alpha will be the inverse tan of 4/3 put into the calculator and get a degree value for it. That's for now. We'll see that there's a more accurate way of doing it later on. So let's go have a look at the 10 kg mass again. Okay, so the 10 kg has an acceleration down the plane, meaning the 6 kg will have the same acceleration to the left. It's got a mass, so it's got a weight. It's resting on the plane pushes back. There's the reaction perpendicular to the plane. It's connected to a string, so there's a tension. Okay, our next step here then is to resolve any forces that aren't parallel and perpendicular into components that are parallel and perpendicular. So the tension and the reaction are good, it's the weight is the problem. So again, two components, and we will use SOHCAHTOA for that. The opposite works out as that value, the adjacent works out as that. And then what you do is you would get rid of this, and then you'd assess that particle according to those forces perpendicular to the plane with no acceleration, and those two which are parallel to the plane with that acceleration. You'd also then look at that particle separately. It's got a mass, so it's got a weight, it's got a reaction, there's a tension, and there's a friction. And you would look at the 6 kg vertically and then horizontally separately. Or if you want to generalize, how you would look at both of them is parallel and perpendicular to the plane. You'd apply F is equal to ma twice. And this one again, parallel to the plane, perpendicular to the plane, you'd apply F is equal to ma in both directions. So, the marking scheme. This particle first, weight, reaction, tension, friction, acceleration, like that. So we would use F is equal to ma horizontally. We'd have T minus F is equal to 6 by the acceleration. F is equal to ma vertically. There's no acceleration, so R will equal 6g when we rearrange it. This one then, we'll have that force minus that force is equal to 10 times the acceleration, where that force there is this thing. And then there's no acceleration perpendicular to the plane, So S minus the adjacent, S minus this, is equal to 10 by 0, so S will equal that. And those will be our formula. So that one is the parallel to the plane there, and this thing is parallel to the plane there. 5 marks for the both of those. We'll keep going. So then when you look at the forces, I think that's you add the two of them together, the t's cancel. You get a value for the acceleration for that of 2.5 meters per second. All right, and then the last part then is to calculate the tension, and you put the acceleration there into the top equation and work it out. And it works out as 55 newtons. Okay, last question for homework. Now, same idea. In this case, we don't know what the mass is, but I'm assuming it's less than 20 kgs. So I'm going to say it's going to accelerate up. This one is going to accelerate down. The forces acting on this will be 20g and t. So the formula will be 20g minus t is equal to 20 by the acceleration. A reaction, tension, friction, and weight. The top three are parallel or perpendicular to the plane. They're good. Resolve that into two components. There we go. If that's 30, that's 30 as well. And we get the value of opposite and adjacent there. Okay, to the marking scheme. Let's have a look. Actually, what were the questions? Show that the constant acceleration of the particle is 2 meters per second squared. So it's released from rest. 20 kg mass travels a distance of that in 4 seconds. All the data is given there for me to use S is ut plus half RT squared. A is equal to 2. Job done. Okay, find the tension in the string. So we have our equations. The quickest way to do it is take the equation related to this particle here. And what we have is T minus 20g is equal to 28. Put in the A value, tension is 240. And then to get the M value for the fourth part, you take that T value, that A value, and put it into the equations you get up here. So we're actually putting together two equations here. This one is parallel to the plane. This one is perpendicular to the plane. I take the R value there and put it in instead of that. Sine 30 is a half. The mass is 2. And we know the tension as well of 240. And then you're just solving for M, which is 240 kgs.